Thank you. Can everybody hear me like this? If the microphone is like here? Yeah, good. Okay, well, thank you very much. I'm going to have to start with a little disclaimer. This is a presentation that I gave last year in Germany. People who were there might remember somebody presenting with one arm in a sling. That would have been me. I really wanted to update this presentation for today, but life threw a lot of different things at me, including a massive hardware failure of my main workstation, and well, simply put, it just didn't happen in time. So the PowerPoint is actually the one from last year. It's also one from a presentation I was supposed to be doing with somebody else who is not here. So it's going to be a bit, as we say in Dutch, houtje touwtje. I see some people recognizing something. So it's going to be a little bit messy, perhaps, but I'm going to do my best to at least get my message across. So this presentation is about a project that I've been doing with one of my customers. It's a company called Unmanned Aviation Solutions, and they do drone photography and drone training and basically anything with unmanned aviation drones stuff, which is really cool nowadays. So it's got that factor. So the first part of the presentation is actually the introduction of the other guy who's not here. So I'm just going to gloss over that. But he's coming from a traditional surveying background, and he has become a drone pilot over the past few years and started his own business doing that. And one of the questions that he had from his clients was if he could come up with a way to survey the quantity of bulk goods of materials in a depot. And with bulk goods, you have to think of coal or gravel or sand, or basically anything that's lots of it and in big heaps. And so, of course you can do that. I mean, it's a simple surveying thing. You can do a terrestrial survey, you can do a GPS survey, but the disadvantages of those are that they're usually very time consuming, and you have to actually be on site and on the heap to do that. And the other option is to do it with a drone and just put a laser scanner on it, fly over it. Because it's a lot quicker. Generally, it's actually a lot more accurate than terrestrial surveying is. And most of all, it's a lot safer. So some pictures of drones. I actually had him come over to my world tour last year and bring a drone with him. So that got everybody interested during the break. He wasn't allowed to actually fly it outside due to aviation rules, but everybody really enjoyed watching or looking at the drone during the coffee breaks. And as I'm sure you all know, drones have a lot of possibilities nowadays. And especially in surveying and data collection, they can be a really, really big help. So the normal process that they do with a drone survey of one of those stockpiles is they fly the drone over it, they take photos and 3D data, and then stitch that together manually and determine which areas have to be surveyed, and it's by and large still a little bit of a manual process. So he's got different software packages to do different parts of the whole project, and it takes a bit of time. And there's a little video that he made showing the standard workflow at the moment. So I'm just going to run through this one to give you an idea of what's going on. This is the actual test site that we've been using for the development of the workspace. So this is the process before FME.
We hebben een project binnen om in te meten, dat is iets boven Gorinchem, Hoog Blokland. En dat gaat over een depot waar een aantal tonnen aan grondstoffen liggen. Op het terrein loopt ook een loopband. Die kunnen we inspecteren door middel van onze warmtebeeldcamera.
So as you can see, the site is not really a place that you would want to go to as a terrestrial surveyor, because it's kind of tricky, it's quite dangerous, it's hard to get to.
Mooie films maken en mooie foto's, omdat het een mooi gelegen object is.
So that standard workflow gives great results, but as I mentioned, it's still a little bit of a manual process to calculate the volumes and put them into a nice report and everything. And so my client came to me and asked, can you do that with FME? Because he wanted to do less manual work and he wanted to be able to do it faster. In fact, he wanted his customers to be able to do it. So even somebody who's not skilled in using that particular software should be able to just upload some files and just get a report out of it. So the question, can you do that in FME? And my answer, whenever somebody asks me that, is always, yes, we can. Of course we can. So this is a little bit of a preview of what's coming out of the whole FME process. So we've got an overview of the entire site. They've indicated a number of heaps that they want to keep track of the volumes over time. So those would be the red outlines. And per heap, they want to see a little map showing where stuff has been added or removed from the heap, as well as a table with the names of the heaps and the volume that's been added or removed from that. This is a slide that should have been much earlier in the process, but anyway, I set up an FME Workspace to make the calculations, to do those comparisons, and then to write the results to a PDF report. It's looking a little bit daunting, the workspace, and it is, to be honest. It's taken quite a bit of time to perfect this. I have to admit that the bit that actually does the calculations, I think I figured it out in about half an hour. And then I spent probably about 3 or 4 days getting the layout and the look of the PDF right. So doing the actual work was the easy bit. Making it look right was the difficult bit. So as a cartographer, that actually is something I'm very used to. So what I've done in order to make those calculations is I've taken the site, the entire area, I've made it into a 2-dimensional grid of points with a certain spacing. And basically I just overlay those points on 2 different terrain models, one from before and one from after. So per point I get 2 Z values and just calculate them. And if you know the spacing that you've put on your grid, then you have the volumes that have been added or removed. It's actually quite simple. So I was in a training session yesterday and Dean mentioned resto calculations as a possible way of doing stuff. So that's certainly something I want to try and see if I can shave some of the processing time off. But for now, this is working. And then per heap, and I think there's 19 heaps in our test set. I generate a little map showing where stuff has been added and removed, because we can actually see that with those calculations, as well as a general overview map So there's a lot of vector to raster processing being done here, and I think that might actually be one of the reasons why this process runs, I think, fairly slow. So there's a lot of raster processing and then writing the end result of PDF. So compiling one page per heap with that overview map with a little bit of text saying this is heap so and so many cubic meters has been added and so much has been removed. There's also some general pages. The problem is when we start the whole thing, we don't actually know how many pages there are going to be in the PDF. And unfortunately, the PDF page formatter kind of requires a hard-coded page number. But there's ways to work around that. And obviously, what I found out, if you don't number your PDF pages consecutively, FME is just going to insert blank pages. So I have to make sure the numbering is right when I start writing the whole thing. So some of the lessons I've learned in the development process of this whole thing, and a very important one is the top one. It's really important to try different approaches to solve your problem. You may find one solution which works. In my case, that was using image rasterizers to do the vector to raster conversion. But when I tried a Mapnik rasterizer, I noticed that there's a very, very big performance gain compared to the image rasterizer. And so since this is something that we want to exploit commercially on top of FME Cloud, anything we can shave off of the processing time would be good, of course. So try out different routes, and that's also why I want to try out the raster calculations when I get back into the office next week. The other thing, PDF styling can be extremely time consuming. Something as simple as figuring out text sizes is a disaster. And I'm coming from a cartographic background, so I'm used to working with PDFs. I do my maps in Adobe Illustrator, so I know how Adobe works. And I found this the most frustrating part of the project is getting the style exactly right. And especially if you've gotten it down to the point where it takes a couple of minutes to process. Every time you make a little change, you have to hit run and then wait another 5-6 minutes for it to show the result. It's really, really frustrating. There's also some positive lessons that I've learned. So when FME 2017 was introduced and FME Cloud 2017, they introduced the new instance sizes, instance options. And running it on 2016 standard, our test case took about 7 minutes to process. Running it on the 2017 starter instance, so the smaller one, only 3 minutes. So the FME 2017 starter instance is actually faster, at least for our case, than the 2016 standard. Great, I love it. It's a work in progress. I must admit, we're not quite done yet. This is something that unfortunately hit a bit of a slump due to various reasons, so we're not at the point yet where we can commercially exploit it. Hopefully that's coming soon. So hopefully next year I can, during my world tour, I can officially unveil it, or I don't know, have a big party for it. But yeah, I think that's what I'd like to show you about my project. I hope it's been interesting for you. And if there's any questions, I'd be happy to see if I can give you an answer. Yes?
What are some of the other workarounds you use in PDF styling?
Try, and try until you get it right. I must say the PDF page formatter is great for putting different parts of your page layout on different positions. I've used other options to generate PDFs, and I've had to rely on relative positioning and shifting data a little bit to create space around it. But with the PDF page formatter, it's a lot easier. So I'm really happy with that one. Yeah, I don't think there's any other nasty workarounds that I've done. Any other questions? Yes?
The drone,
Mm-hmm.
Is it actually have a LiDAR capture on it, or is it imagery that you can, because of stereo image, you can then derive a point cloud from?
I think it's imagery and then stereo.
Okay.
although that's not my area of expertise. I just get cool data. I don't care where it's coming from. Anybody else? No, well then, thank you very much.